Welcome back. In this video we're going to go ahead and program our 3D Groot. So we are going to start by looking at our plane, and right now our plane is in our bottom left corner, top of the part. What I'd like to do is set this part up more realistically for how we would put it in a vise inside of a machine. So I'm going to go ahead and rotate my part so that the plane is in the back left corner and the part is sideways, so that it's pretty standard for a Kurt vise, or going up at the back solid jaw would be our XY0. So we're going to go ahead and do that. Transform dynamic. We're going to grab everything, and we are just going to go ahead and rotate this plane, or this part, sorry, 90 degrees on our plane. So now when I put it in a top view, you'll see that my plane is in the back left corner. That's more realistic for going into an actual CNC machine. So to create our machine mill, we're going to go ahead and use default. And then setting up our properties. We're going to go into our tool settings. We'll go ahead and get our feeds and speeds from material, even though we're going to go ahead and select our own most cases. I'm going to assign duplicate our tool numbers sequentially and warn of duplicate tools, and then I'm going to override my clearance values. For my stock setup, because I've drawn this part in 3D and I have a wireframe box everywhere, I don't have to actually know the size of my stock, because I kind of did that when I drew the part. So I'm just going to select all entities, and then it's going to determine where it needs to put these stock values. So I'll green check that. And now my stock is set up around the entities that I had selected for the part. So my first toolpath that we're going to run, we're going to go ahead and rough this out with a 1/4 inch end mill. The roughing and finishing toolpaths that we're going to use are not over here on the left. These are all our 2D toolpaths. With this video we're going to use 3D toolpaths. So I'm going to go ahead and use this OptiRough. And then when it pulls open the OptiRough, the first thing it asks is for the model geometry. So we're not necessarily selecting chains at this point. We're going to be selecting 3D model as what we want the computer to generate our program from. So it's got highlighted this machining is just a default group. It's got 0 entities. So we have to add the entities we want to use. So you come down here to this white arrow, and now I can just highlight all of the entities that I want in the program, which this is going to be everything. And selection, now you can see I've got 7 entities. And now this is asking for the wall stock and floor stock. This is your stock allowance. So when you're roughing a part, you want to leave extra stock so that you can come in later and finish it with to 0th stock allowance with a nice finished toolpath. So I'm going to go ahead and leave 15 thousandths of stock on my walls and my floor. Now my toolpath control, this is where you could add a containment boundary. So if you wanted just to machine a small area, you can add a chain or a boundary in that area. We're just going to machine everything. For my tools, I'm going to go ahead and go to my library, and you're going to want to filter to where you only have a a flat end mill, and we're going to use a 1/4 inch flat end mill. Now for our feeds and speeds, I'm going to run this end mill at 5,000 RPM, and I'm going to run a 1% chip load, so 0025. And then I'm going to put my plunge rate at half of my cutting rate. So under my cut parameters, my step over, I'm going to put that at 60% of the tool. And then my step down, I'm going to leave it 10% of the tool. So we'll take 150,000 step over, 25,000 step down. That tool should be able to handle that no problem. Under my transitions, what I'm looking at here is this skip pocket smaller than 220% of the tool. So the thinking behind this this here is if you're using an inserted cutter, you can't plunge an inserted cutter. It has to be able to move, or else the stock is going to go up into the center of the cutter where you have no inserts. Well, we're using an end mill, and we're going to use a center cutting end mill. So technically we can plunge even though it's not very good on a tool. But I do want to be able to get into smaller areas than 220% of the tool. So for these type of tool paths that I'm using a sharp center cutting end mill, I'm going to go lower that to 150%. It may do a little bit of plunging at times, but for the most part it's going to be okay going into a 3/8 area. Now my steep shallow, this is going to detect the limits in which I want this tool to go. So when you look at your part, it's broken up into 2/4 inch segments. The top 1/4 inch where the Groot is, and the bottom 1/4 inches we're just going to leave alone. That's going to be clamped in the vise. So I don't ever want my tool to go below this area. So this isn't a place where I can set that. So you can detect the limits, and it's going to say that the top of the Groot is 11 thousandths below the stock, and the bottom of the Groot is a 1/2 inch below. Okay, so what I want to do is I want to machine everything from 0 to minus 1/4 inch. That way, that tells my tool no matter what, you never go below 1/4 inch deep, which will keep us from ever machining into our vise. Okay, linking parameters are a little bit different in this. We're not going to really touch a lot of these values unless you're seeing a lot of entry exit moves that are larger than you need or expect. Sometimes I'll make these values a little smaller, but my clearance plane, I'm just going to put it at 1 inch as opposed to 2 inches. And then under my coolant, I'm going to go ahead and turn that on. And we're going to green check that. Now the calculation for 3D toolpaths takes a little longer than the 2D. And when you look at this little green box right here, this means that it's calculating. Okay, it's processing. It takes a lot longer to look at all these surfaces and calculate a toolpath, but that's what we got right here. It looks pretty good. That 1/4 inch end mill is machining all of these areas, and then now we're going to go ahead and we're going to do what I like to call a re-rough toolpath. So I'm going to go in with the next size smaller tool or an 1/8 inch flat end mill, and I'm going to tell it only machine the areas that the 1/4 inch couldn't get. Okay, it's kind of a re-roughing toolpath. So to do that, we're going to go ahead and just do OptiRough again. Now our wall stock and our floor stock, we're going to leave the same. Our toolpath control, we're not going to select certain areas to go into, so we're going to leave that the same. But under our tool, we're going to go and grab an 1/8 inch end mill. So, same thing, we're going to run 5,000 RPM. Our chip load is going to be 1% of the diameter, 0.0012, 24 inches a minute. We'll go ahead and put our plunge and our retract at 1/2 of that. Now we're going to use the stock tab. Now this is what's going to tell it to, hey, only go in and machine what has not been cut yet. So if I turn on this rest material, now I have a few options here. I can tell it a roughing tool. I can tell it all previous groups. We're going to go ahead and use the all previous groups. So it's going to say look at the previous toolpath and use that to determine what stock is left to cut. I'm going to ignore my small cusps so that it doesn't cut a lot of extra. Okay, under my cut parameters, we're going to stick with 60% step over, 10% step down. Transitions, same thing, skip pockets smaller than. I'm going to change to 150% of the tool. It'll be able to do that without a problem. My steep shallows is already set. Everything should be good. I can green check that. Now it's going to give me a warning saying surface operation does not contain any machining surfaces. That's because under the model geometry, I have to go select these surfaces again. Okay, so we'll calculate that dirty. Now this is the warning I was looking for. The containment boundary is required for all roughing. The minimum maximum limits of the machine data will be used. So it's just telling me it's gonna use the extents of the part, which is what I want and why I didn't create a boundary. So now that's calculating. It's going to take a second. These do take a little longer. So now you see this facets down here. What it's doing is it's looking through all of these little facets around this STL, which an STL is a lot of facets. Now it's calculating, and it'll get done here in just a second, and we'll be able to see our toolpath. And there's our toolpath. So you can see the difference between this toolpath and the previous toolpath. The previous toolpath machined all of this stock away. Now this current toolpath is only machining the areas in which that 1/4 inch could not get into, or where the computer has determined that there is some extra stock that it needs to machine. So it is machining a little more than I'd like it to, but it's going to be okay for this part. So we will move on to our next toolpath. Okay, now we're going to go ahead and cut our flat surfaces. So before I like to cut any 3D shape, I like to have my flat surfaces cut to 0. So what we're going to do is we're going to go up here and we're going to use this horizontal toolpath. And what this is horizontal toolpath means is I'm only going to cut surfaces that I detect as flat. So under our model geometry, we'll go ahead and we'll select everything. Oop, I missed it. There we go. And then for my wall stock, I'm going to leave 20 thousandths. But my floor stock, I'm going to put at 0. So because we left 15 thousandths in the previous toolpath to go around all our roughing, now I'm going to leave 20 thousandths. So this 1/8 inch end mill is going to go in there, and it's not actually going to touch any of the walls, but it is going to touch all the flats. So when we grab our tool, our 1/8 inch flat, we're going to put it back to 5,000 RPMs. Our 1% chip load. Put our plunge and our retract right at half the chip load. Under my cut parameters now, I'm going to use number of depth cuts as 2 and my step down of 10 thousandths. So it's going to machine the first section to get it at a solid 10 thousandths and then take the other 10 thousandths away. It'll make it look really nice. For my XY step over, 45% of the tool is fine. You can actually make that a little bigger if you want. 55% of the tool. We're not going to mess with anything else except for we're going to turn our coolant on. And we'll green check that and let it calculate. So, and then we'll see that it just cuts these flat areas with that 1/8 inch end mill and makes it so that all we have left, there we go, see it's a very nice tool path, cutting the flats, taking 2 passes, getting that down to 0. It's going to make it look really nice on your parts. And then all we have left to do is to cut this 3D. So to cut this 3D, we're going to use a hybrid toolpath. This is what I like to use. The way the hybrid toolpath works is it cuts any wall areas first with more of a Z-level type toolpath or a waterline, and then it'll come back and do a form of raster type pass over everything that's a horizontal surface or up to a certain degree. When it comes to our tool on that tool path, we're going to use a 3/16 ball cutter. So let me go ahead and get this model geometry selected. We're going to leave 0 on everything for our stock allowance. We're not going to use a chain, but we're going to use a 3/16 ball cutter. So my thought process behind these tools is I like to rough apart one cutter size smaller than what I'm going to finish the part, especially when switching over to a ball cutter from a flat. So I roughed this part down to an 1/8 inch flat, so that is one size smaller than a 3/16 ball cutter. That way I've dug out all the corners smaller, and that it lessens the ability for that ball cutter to chatter when it goes into a full engagement of stock on all sides. So that's the thought process behind it. So that's why we're selecting a 3/16 ball cutter. So we're going to select tool from library, filter. I'm going to use ball and 3/16 here. Okay, we're going to go ahead and change our spindle to 5,000 and 0.0018 is our 1% of our diameter, and 18 for my plunge and retract. Under my cut parameters, I'm going to go ahead and go with a 5,000 step down, 5,000 step over for my 3/16. I'm coming up with that numbers from surface finishes and what I want it to look like, so I'm really just giving you that number. There we can go over a whole nother lesson on how to figure out scallop height with some different software that I use, but for now just go ahead and go with this 5,000 step down, 5,000 step over, and then you see this limiting angle here. We're going to change this to 60 degrees. So what that's going to do is it's going to say anything from 90 degrees to 60 degrees. We're going to go ahead and cut it as if it's a wall. And anything below 60, so 60 down to 0, we're going to cut it as if it's more of a horizontal surface. And this is what it'll get your software to create less large scallops in the part, and it makes it look a lot better. And it's how it determines the hybrid, what is a wall and what is a side. Okay, and then another thing we want to look at is the flat detection. Okay, I don't want to cut the flats because I've already cut those with an 1/8 inch flat cutter. It'd be a big waste of time. So what I'm going to tell it to do is ignore the flats. So it should only cut this Groot shape. And then under my steep shallows, I do not want it rolling over these edges. So I'm going to go ahead and do a minimum depth of 0, maximum depth of minus 0.25. And that should get me a good looking tool path. Turn my coolant on and we'll green check that. And this one might take a little longer to calculate. Okay, so here we go. I did not like the looks of this tool path. Way too many lifts, and the arc lead-ons, lead-outs are way too large. I'm going to try to make this look a little better by changing a few parameters. So first of all, let's go into our linking parameters, and this is where we only have 15 thousandths of stock on this, so we don't need all these 75 thousandths entry exits. So we're going to change these to 20 thousandths. Okay, we don't need 100 thousandths of ramp height, so we're going to change that to 30 thousandths. Our clearance height of absolute of 1 inch is a little excessive for all these little extra moves. So we are going to change this clearance plane to 100 thousandths absolute above the part. Now remember, the top of the part is 0. And then for our open contour, we're going to change it to zigzag. Now when we recalculate this, you'll see that we've cleaned up a lot of that excess move that we don't need. Okay, so this looks much better, and it's really going to cut the detail out with this 3/16 ball cutter. So it looks good. Okay, so now with this next toolpath, we're going to go ahead and run a pencil trace on here, which is a remachine with a smaller ball cutter that's just going to go in and cut the areas that need to be sharpened up, or areas that stock was left behind. So to do this type of toolpath, we're going to run right here, it's called a pencil. Okay, to select our geometry, we're going to go ahead and select everything again. We're going to be leaving 0 stock on the walls, 0 on the floors. I'm going to use a toolpath control this time, just because I found with this pencil trace, even if I put in my limits, my steep shallow limits, it still likes to roll these corners or roll these edges a little, even though I don't need to cut out there. So what I'm going to do is just select this top boundary, and then I'm going to tell my toolpath to stay inside of that boundary. And that'll make it so it doesn't even think about cutting any of these sharp corners or edges or anything with this tool. Now we're going to use an 1/8 inch ball cutter. So we'll grab our ball cutter, 1/8 inch ball, 5,000 RPM. 0.012. So at 24 inches a minute, looks good. 12 on the plunge and the retract. We're going to be using stock again. So, and I'm just going to go all previous groups. So it's going to look at all the previous cutters that have ran and then determine what this cutter can actually still cut, and that's how the pencil works. Under cut parameters, we're going to put our step over at 3 thousandths. And then where it says maximum number of offsets, this is how many step overs is going to be required. I don't want to have a maximum. I want to let it determine however many it needs to. So I'm going to uncheck that box. So for my steep to shallows, we'll go from 0 to -1/4 inch again. And then make sure our coolant is turned on. And then we'll go ahead and calculate this one. And sometimes these pencils, they can take a little bit longer to calculate. So if you're doing this and it's taken 2-3 minutes, that's fine. If you want to see what's happening in this calculation, especially when this turns green, you can go into your View tab and turn on the multi-threading. And the multi-threading will actually give you a little bar, and I'll show you here in a second. There we go, multi-threading, and this will actually kind of show you the progress of the toolpath a little bit. And so you'll know when it's getting closer to getting done, or to make sure that it's actually doing something and it hasn't just froze on you. So looks like we're getting pretty close here. Okay, so with that done, now we can go in and we can see that this 1/8 inch ball is kind of sharpening up a lot of these details on Groot of areas that it found stock remained from the previous cutters. So that looks good. Now I'm going to go ahead and just do the engraving in the IM group. So with that, we're going to go back to one of our 2D toolpaths. We're just going to run a contour. When it comes to the chain, I'm just going to use the window feature and draw a window around the letters that I want, and then I got to click a start point. Good. I'm going to use that same 1/8 inch ball cutter. Same parameters we've been running. For my cut parameters, I'm going to turn my compensation type to off for engraving. And then my lead and lead outs, I'm also going to turn off. I don't want that extra. And then my linking parameters, where I'm going to set the depth. So I know that absolute, that's 1/4 inch deep this surface is. So I'm going to go ahead and go 0.256. That'll have a 6 thousandths deep engraving, and that should work well. So we'll green check that. We'll turn our coolant on. Green check that. And now you see the engraving there. So now I'm going to go ahead and run the simulation on this, and we'll see what it looks like with all the toolpaths done. So we'll turn everything on. Come to the verify screen. I'm going to just turn my speed all the way up, and when that gets done loading here. Looks like it's going to take a while to get this loaded. Alright, there we go. I push play. And there's our first roughing tool, which we looked at earlier. Now here's the next tool, which is doing the 1/8 inch flat. That's kind of doing the re-rough, which is getting it ready so we can run that 3/16 ball and not run into anything. Now here's the 3/16 ball doing its hybrid toolpath, and this will be the toolpath that probably takes the longest to run time-wise. So you can really start seeing the detail come out from the Groot. So it's looking pretty good. And then usually whatever you see it look like in this verification, at the machine, the actual part, the aluminum, I think looks better than what this verification looks like. So this should be a pretty sharp looking little part here that we're machining. Okay, so it looks like this is just about done, and then we're going to run the 1/8 inch ball remachine. And this remachine is just sharpening up all of these areas that 3/16 ball could not reach down into. And you can kind of start to see the thing sharpen up a little bit. You look down around underneath his chin there, down along the bottom. Okay, and this is just about done, and then we'll see the engraving, and then the I am Groot engraved down in the bottom, and that looks pretty good. So that is our first 3D project and how you use Mastercam to do some 3D machining. Turned out pretty neat. Look forward to seeing what you guys can come up with. So go make sure you subscribe for more videos and hit that like button.